Today we're going to talk about a very powerful rule to differentiate functions, the chain rule. The first objective we're going to tackle is understanding the chain rule is required to differentiate a composite function. So from your algebra days, one's function inside the other. So we have g of x inside another function f of x. So let's see something that we would look at when we're dealing with that. So let me just show you an example of why you need it. So I have a function 4x squared minus 12x plus 9. All of us know the derivative of that is negative 8x minus 12. Take a second to look at it. That is the correct derivative. Now, let's look at the factored form of the same function. So let's, if I multiply this out, first term squared would be 4x squared, 2 times my product. Well, my product is negative 6x, 2 of those is negative 12x, and last term squared is plus 9. So that's the factored form of that. Now, if we use our power rule, bringing the power down in front, so plopping my 2 right there, reducing the power by 1 and calling it a day, is that the correct derivative? Well, we know that is the correct derivative. So does this equal that? Is there any? Well, no, it doesn't. So we're going to have to use the chain rule when we have a composite function, a function inside an outside function. So what we can do is, first of all, we have to recognize the inside and the outside parts, okay? So that's the objective here, second one. Let's go ahead and recognize the inside and the outside of a composite function. We did this in pre-calculus. So we're going to call f of x the outside function. We're going to call g of x the inside function. Outside, inside is a pretty term we use in class. So let's see. So I'm going to tell you a composite function, f of g of x. I'm going to tell you that is 3 times quantity 2x plus 5 squared. When I look at my outside component, that is 3 times an input. I use that language specifically, 3 times an input squared. Well, if I plug into the input 2x plus 5, well, I end up with my composite function 3 times 2x plus 5 squared. Do a couple more just to check. F of g of t, well, my inside function is g of t. And let's say the whole thing looks like 3 times the sine of 2t squared plus 1. Well, the outside parent function, or the outside function, not parent, just t inside, that's the key you're looking for. Just t inside is not a composite function. 3 times the sine of an input plus 1. Well, my inside input replacement would be something other than just plain old t. It would be 2t squared. Okay, and you'll have some practice looking at those as we get through. Objective 3, let's differentiate a composite function. Well, first of all, we have to have the chain rule. So in rainbow colors, here is the setup to find the derivative of a composite function. So let's set that apart. Let's change a color so it's a little bit more standout. So that's good enough. So let's say we have the derivative. The outside function is f, the inside function is g. To find that derivative, we take the derivative of the outside function, leaving the inside part alone. Don't do anything to it. Leave it inside. Taking the derivative of the outside, leaving the inside alone. Then we're going to multiply that by the derivative of the inside. So we'll see as we move through how that is, and you are welcome to go up and try on our earlier situation to see if that works when you're replaying the video. To keep the video short and to the point, we will just call it a day on that. So now, derivative of the outside, leave the inside alone, times the derivative of the inside. Those are the not mathy terms, but that's a good way to think about it, help you work through it. So let's talk about a function y. Y is equal to a composite function, 2x minus 6 squared, quantity to the fourth. So we're recognizing that the outside function, let's go ahead and put that up here. So my outside function, my f of x, is going to be x to the fourth, some input to the power of 4. Input to the power of 4. My inside function there is the input as you see it, 2x minus 6x squared. So let's have a look. Let's have a go at this. All right. So now dy dx, the derivative of y with respect to x. So my dy dx is going to look like derivative of the outside function. So we got our 4 down here. Leaving the inside alone, so that's going to be 2x minus 6x squared. Reduce the power by 1. So that was derivative of the outside, leaving the inside alone. Now I have to multiply by the derivative of the inside. So the derivative of the inside is just as it looks. So the derivative of that is going to be 2 minus 12x. And for now, we'll call that done. Derivative of the outside, leave the inside alone, times derivative of the inside. Let's do a different example. Find f prime if f of x is the cube root of tangent of x. So we should probably rewrite this. Let's rewrite that first. Let's see, f of x is actually tangent of x to the 1/3 power. So my outside function is x to the 1/3. My inside function is tangent of x. So to find its derivative, f prime of x is going to be derivative of the outside. So that's 1/3 times the quantity left alone. Reduce the power by 1. 1/3 minus 3/3 is negative 2/3. Now multiply it by the derivative of the inside, secant squared, and just a little cleanup here. So we've got secant squared in the numerator, and we've got 3 times tangent of x to the 2/3 power in the denominator. So we could probably clean that up a little bit more, but we'll save that for a later lesson, as our objective is to keep we're focusing on the chain rule. We could rewrite that. Let's keep going for now. I believe the last example would be a way that I traditionally write quotients as product rules. And the way you can do this is actually, before I take g prime, let's rewrite g. So there is my g, -5 divided by a 2-term denominator. So we can't break that up. But what I could do is I could rewrite this as -5 times the denominator to the power of -1. So currently it's to the power 1. If I push that up in the numerator, it becomes -1. So it could be -5 times the sine of x plus 2x squared to -1. Now I have a product rule. So actually, in this case, it's not even going to be product rule because my coefficient is just a coefficient. So let's just do the derivative. Let's do the power rule as we've always done it. So -1 comes down, multiplies the -5, so it becomes +5. Leave my inside alone, sine of x plus 2x squared. Reduce that power by 1, -2. Multiply that by the derivative of the inside. The derivative of sine is cosine. The derivative of the next term is 4x. And there we go. Well, we'll put that down in the denominator just to clean it up. So we've got 5 is in the numerator. This positive power right here is in the numerator, cosine of x plus 4x, all over what is in the denominator, sine of x plus 2x squared to the power of positive 2 now, because it's in the denominator. Okay, that is introduction to the chain rule. The practice I would like you to do is on page, I have it written down, page 137. And I would like you to do problems 7 to 21 odd. Use this video as many times as you need. You also have Calc Chat to look at some of the solutions. Hope this helps.